Okay, for this tutorial, we will cover section 2.1.5 to 2.1.6 from OpenFoam user guide. So what you did last time, we did a case for the cavity. For this time, what you have to do is now we will do the same case but with the finer mesh, and we will copy the some of the directories from previous case to this new case. Okay, now let's get started. Now we will create a new case named cavity find that is created from tutor cavity. Okay, and now we will make a new directory. Okay, so we have to go to cd tutorial composable OpenFoam. Now from this OpenFoam we have to make a new directory. Okay, so we will make a directory name cavity find. Okay, so make directory. So we just created a new directory called cavity find. Now what we have to do is we have to copy some of the files folder directory from previous case from tutor cavity to this new case. So what we have to do is we have to copy those directories. So cpr tutor cavity and constant. So what we're doing right now is we are copying constant directory from tutor cavity to this new directory called cavity find. Okay. Now we just copied constant from tutor cavity. It was from our previous case to this new directory. Now we have to copy our system directory from our previous case to this new case again. cpr Okay, now we have copied both directory from our previous case to this new case. Now we have to be in our case now, new case. It's a cavity find, so cd cavity find. Okay, now we are in our new case. You can go back to the tutorial and you can check if you have created a new directory here. It's a cavity find, and we have already copied the two folders, constant and system, from our tutor cavity. Okay. Now we want to increase the number of cells in the mesh by using block mesh. So what you can do, you can either open a block mesh from the terminal, or you can either go to the Windows and open block mesh. Okay, so if you want to open it from the terminal, gedit. Okay, and that's the gedit is a text editor we used before. Okay, and then we have to go to the constant. Okay, then polymesh. Then we're gonna open block mesh. Block mistake. Okay, now we will open a block mistake. Okay, now what we have to do is we just have to change this one. Okay, we just need to refine the mesh. Let me increase the mesh 40. We are just doubling the number of cells. Okay. Mesh and save it. Okay, now we have to run this block mesh by tapping block mesh. Okay, now we have just created a mesh. So in this case, we will map the results, final results of the cursor mesh from tutor cavity onto the final mesh of cavity find. Okay, from the terminal window, so what do you do from the cavity case directory? We will map the results from the tutor cavity to this find cavity. Okay, so map build. Okay. Okay. So when you are mapping the results to a final mesh, you should get target mesh size greater than source mesh size. Now we'll go to our control text where we will change the time step and end time and other feature. So here we need to change the end time from 0.5 to 0.7 seconds. Okay. and we need to change delta t to 0.0025 because in order to get the current number less than 1, we need to change this delta t from 0.005 to 0.0025. Okay, and right control this one, we change this to runtime, make sure this is runtime, and right interval to 0.1, and now make sure you save your file. Okay, so from now onwards the user should experience running OpenFoam as a background process, and we will create a log file and to see what you have done and to check our results. So we have to now execute OpenFoam. So OpenFoam it doesn't matter what you name a log file, or we just want to save a log file to see what you have done and to take our conversions and to plot a graph. Now we have to launch a para view, so type paraform. Okay, click apply, make sure this is by you, and you make sure this is 0.7 second, the time is 0.7 second. Okay, now we will plot a vector plot for this case. Now go to filter, resend, it's a cell center, hit apply, filter, resend, glyph, and then make sure the scale mode is turned off and edit, set scale factor to 0.005, click apply, and you can see here change this back to U, and this is the vector plot for the velocity for this final mesh. Okay, now we need to overlay the vector for tutor cavity, the case from our previous case. Okay, now we have to go back to the command window and then type, we need to change the directory to the tutor cavity, the cd tutor cavity. Okay, so we are in our tutor cavity directory now, and now type touch tutor cavity.openFoam, and now go back to the para view. Okay, file, open, go to tutor cavity, and then open this tutor cavity.openFoam right here. Okay, and click apply. Okay, and change this to U, and make sure this is in 0.7 second. Okay, now we will create a vector plot for this case as well. So filter, resend, cell center, apply, filter, resend, glyph. We'll do the same process. We'll turn off this scale mode and change this to 0.005. Okay, and apply, and go to the display tab. Okay, and change color by to solid color, and now here we can see the vector plot for the final mesh and the coarser mesh. Now we need to plot a graph. So what do you do from our tutor cavity this directory? We'll type form, we'll type form cal components u. Okay, so when you type form cal components u, it reads in the velocity vector field from the time directory, and it will write a scalar fields right here. You can see scalar field ux, uy, and uz. Now we need to open up paraform again. Now go to the terminal again and type paraform. Okay, now make sure your tutor cavity OpenFoam is highlighted and click apply. Okay, now go to by U and make sure it's 0.5 seconds right there. Now to display a graph, you go to filter, then go to data analysis, then plot over line. Okay, Now we'll change this point 1 and point 2. Point 0.05, 0, 0.005, 0.05. This will be point 1 and 0.005. Okay, and make sure this resolution is 100. And click apply here. Go to display. You can just drag this, make it bigger, and here attribute mode point data, use data array, so it's arc length, and you select U0 here, and here you can change the line color, thickness, style, marker. Okay, now go to the third option here, third button here. It's edit view option, where you can label the graph and specify the axis range. Okay, now here you can put the title in the x-axis, like left axis. You can specify the data range, and same with the bottom one. Okay, so the case now we will do is located in the OpenFoam directory. Okay, you can go here. It's named cavity grade. So this is all set up and it's ready to run. So from our terminal window, we need to go to this directory. So cd, now change cd cavity grade. Okay, so now we are in our cavity grade. Okay, this screen. Now we need to run a block mesh. Block mesh. Okay. Open paraform. Go to here, wireframe. Okay, here you can see the mesh towards the wall had the smaller cell size, because I think it's because of the large variation in the velocity near the wall. Now you can close this one. You go to the cavity grid and system, and go to your control deck, and make sure your start time is 0.7 seconds. It's the same as the cavity find case. Okay, and make sure the end time is 28 seconds. We'll leave this delta t 0.025 and right interval to 40. Now what we'll do, the same thing we did before. We will map the solution, from our cavity find to this new cavity grade. Okay, so do map field again. Map field, cavity find, consistent. Make sure you always use consistent. Okay, now we will run OpenFoam. So OpenFoam. Okay. Also, you can view a log file. So cat log to make sure it ran correctly. So it's good. Our command number is less than 1. Now we will go to the paraform again. So paraform. Now we're gonna get all the graph. Okay, and go here, then hit apply, and make sure you are in your U. Make sure you are in your 0.8 second, the last time step. Okay, now we need to create a graph. We go to filter, recent, plot over line. We'll do the same 0.05, 0, 0.005, 0.05, okay, 0.1, 0.005, okay, resolution 100, apply, go to display, use data array, arc length, and change this to 0, 0. Okay, and you can also compare other graph. You go to open, and you can open the cavity find to the cavity or whatever, and you can compare all the graph.